before we get started, all right, guys, before we get started, are there any questions over the homework? So what we're doing today is kind of an extension of what we did yesterday. Now, these three here aren't on the note sheet, but we talked about these yesterday, finding the nth root of a, where they give us the value of n and they give us the value of a. So if we look at the first one, n is 3, a is negative 131. So really just trying to find the third root of negative 1,331. According to our root properties, if we take the odd root of a negative number, bless you, we have one real root. Bless you. If we take the odd root of a positive number, we have one real root. And if we take the odd root of 0, we still have one real root. Doesn't matter what it is, we can take that root. And at this point here, we can go 3 cubed root of negative 1,331. And it tells us that the cubed root of negative 1,331 would be negative 11. Now the second one, again, not on our note sheets, they're just here. If we're taking the sixth root of negative 258, again, we would look at our even root properties. If we take the even root of a positive number, we're going to have two real roots, the positive and negative case. If we take an even root and what's inside the value of a is 0, we're going to have one real root. And if we take the even root of a negative number, we have no real roots. So we wouldn't say no solutions because there are solutions, there are values that work, they're just not real. And for most of this chapter, and what we're going to look at this here, we're only going to be looking at the real cases. We're only going to be looking for the real values of x, the real solutions. Because it is possible to actually find the complex solutions in these values with most of the equations we're going to look at. It just requires a lot of processes and formulas we're not actually going to cover in this chapter. So instead of trying to broaden it out and cover all of it, we're just going to focus on the real solution. Now, rational exponent properties. We will cover this in 5.2. I just kind of want to look at it briefly. We'll talk about it in kind of a shallow depth at this point. We're going to look more at it in 5.2. And one of these is that a to the m over n is equal to a to the 1 over n to the mth power, nth root of a to the nth. We can break it back apart into this here. Same as if it's negative, we can do it, but it's going to end up in the bottom of the fraction. Now, the reason I bring this up, or the reason this is helpful, is so let's look at the first one, 16 to the 3 halves. Let's say we don't have a calculator to actually work this out. So according to this here, we can rewrite this as 16 to the 1/2 to the third power. And from here, we can rewrite 16 to the 1/2 in radical form. So we'd have our radical and a, that base is 16, that number 16 would go inside the radical. The 1 on top of that fractional exponent would be attached to the 16. Thank you. Which would tell us that inside the radical we have 16 to the first, or just 16. The 2 on bottom would go into the index. But a 2 in that v, an index of 2, is understood as a square root. So rewriting it in this form tells us that we have the square root of 16 cubed. Well, the square root of 16 is 4. We know how to do that. And then 4 cubed is 64. 4 squared, 4 times 4 is 16. 16 times 4 gets us 64. We have this here. But if we had a calculator, 16 to the 3 halves is indeed 64. We get to the exact same place, the exact same location either way. And if we look at 32 to the negative 3/5, first thing we'd want to do is make that exponent positive, so we're going to move it from the top of the fraction to the bottom. So we have 1 over 32 to the 3/5. And according to this property, we can split this up as 32 to the 1/5 to the third power. Now our 32 to the 1/5 inside here, we can rewrite this in radical form. The 1/5, the 1, that number that's going to be attached to the exponent with the 32, which is just telling us we have 32 to the first, which is just 32. The 5 on bottom is going to be the index, what root we're taking. So really we're saying that we have 1 over the 5th root of 32 cubed. So our 5th root of 32, we're trying to find out what number times itself 5 times is 32. 32, in the grand scheme of things, is a smaller number, so its 5th root should be even smaller. And it actually works out to be 2, because 2 to the 5th is 32, telling us that we have 1 over 2 to the third. 2 to the third is 8, which is really telling us 32 to the 3/5, negative 3/5, is 1/8. Or, let's see what the calculator tells us. 32 to the negative 3/5 is 1/8. Questions on this so far? So really, for the most part, I would use these processes and these procedures if the calculator is going to give us an irrational number, a non-repeating, non-terminating decimal. It won't leave it in radical form or simplified form. Then we really need it. So for like 64 to the 4/3, first thing I do is just plug it in and check and see, does this give me a integer solution or rational solution? If it does, it tells me that it's 256. This is yes. We're done. If it gives me this decimal, this irrational number, and it wants it in simplest radical form, okay, now we're going to start applying these theorems, these rules to it to see what is it going to reduce, how are we going to have to reduce it. Here, we don't have to do anything to it. It told us what it is. Questions on this one? 16 to the negative 5/4. Helps if I actually type both numbers in. 1/32. Any questions on this here? It's a lot of what we did yesterday, just starting to apply some of this in. We'll apply more of it in 5.2, what we're going to do tomorrow. We have one other main thing we're doing, solving nth roots. We've done this before. We've already done a type of this at this point. We just didn't call it solving equations using nth roots. We actually called it solving equations by using the square root method. We just said n is 2. And it works for any of these here. Now, the main way we can do this, the nth root, just like the square root method, the only variable that shows up is either to a power like this here. We just have x to the 5th. We don't have an x to the 4th, x to the 3rd, x squared, x, any other variables. We just have the 1. Or the only place that variable shows up is inside a set of parentheses. That's to an exponent. And the rules are still the same. Or our steps are still the same. Step number 1. Get the term to a power by itself. We want to get whatever that term to a power is by itself. Using addition, subtraction, multiplication, division, we want to get it by itself first. So 4x to the fifth equals 128. What do we need to do first to get that x to the fifth term by itself? So what's with our x to the fifth? Four. So what's with x to the fifth? What is with x to the fifth? 4. We need to get it by itself. What do we need to do to get it by itself? Divide both sides by 4, because 4x to the fifth divided by 4. 4 divided by 4 is 1. So we just have x to the fifth. 128 divided by 4 is 32. Is our term to a power, that x to the fifth by itself? Yeah, there's nothing else being multiplied by it. There's nothing being added to it. It is by itself. So once we get it by itself, we want to apply the nth root to both sides. And follow our root rules. And follow our root rules. Root rules, what we did yesterday with our type of real roots that we can get. So now that we have this here, we're going to apply the nth root. Now because our term to a power is to the fifth power, that means we're going to apply the fifth root to both sides. Because the fifth root of x to the fifth, those will simplify to x. Now the fifth root of 32. I'd grab a calculator, plug it in, see what the fifth root of 32 is, and it is 2. Okay. So we did the first half of that. We applied the nth root to both sides, but we do need to follow our root rules. Since we took an odd root, according to those rules, if we take the odd root of a negative number, we get one real root. Well, we didn't take the odd root of a negative number. We took it of a positive number. Well, the odd root of a positive number is still one real root. So that means 2 is our only possible choice. So x equals 2 is what we have. Now, our last step we actually didn't need for this would be solve for x, solve for that variable. But because x is already by itself, x equals 2, we're done. We don't have to do anything with this. Questions on anything we've done so far? Fundamental theorem of algebra. We had that last semester. We've talked about it time and time again. States that for any high degree polynomial function, there exists at least one solution in the complex plane. That's not why I'm bringing this up. The corollary of it said that for any high degree polynomial function, the number of solutions is equal to the degree counting repeated solutions. So the degree of this one here is 5. So there should be 5 solutions, yes? How many solutions do we actually find? 1. So let's go back to the instructions and see what it said. Find the real solutions. We took the fifth root of both sides, and according to our root rules, there's only one real solution. That means those other 4 solutions that exist for this function, this equation, are going to be complex. They're going to be irrational solutions. They are non-real solutions. There are ways to find it. They involve more trigonometric kind of higher function or equations we just don't cover yet. In most of the chapter, again, We're just looking at the real ones. And the only real solution for this here is that x is equal to 2. That's it. We're done. Questions on this here? Let's look at the next one. X minus 3 to the fourth equals 21. We can use the nth root. We can solve this by the nth root method because the only place the variable shows up is inside those parentheses to the fourth power. If we had a variable outside of those parentheses, we would have to get it so the only place it shows up is inside. We'd have to do a whole lot of extra work. Here, it's nice. We're good. We can do this method. First thing we want to do is get that term to a power by itself. Is there anything being multiplied by our term to that fourth power? Do we have anything being multiplied out in front of it? Do we have anything being added to it or subtracted to it? Well, we do have the minus 3, yes? But is that inside of our term or outside? Inside, so that doesn't matter because we want to get that to the fourth power, that term to the fourth by itself. It is by itself, yes? So there's nothing we have to do for step 1. It is already by itself, which means we can move on to step 2 and apply the nth root to both sides. In this case, we'd be applying the fourth root to both sides because the fourth root in this fourth power would simplify, leaving us with x minus 3. Fourth root of 21. Fourth root of 21 is 2.140695143. It's irrational. It's a non-repeating, non-terminating decimal. It does not simplify nicely. So we'll leave it. We're going to leave it as the fourth root of 21. There's no reason to reduce or to, not so much reduce, but to approximate these decimals until the very end, until we finish solving. Now we do need to follow our root rules. We took the even root of a positive number, yes? If I take an even root of a positive number, we should have 2 real roots. We should have a positive case and a negative. Whenever we take the even root of both sides, we have to put that plus or minus. So we're saying that x minus 3 can equal positive fourth root of 21, and it can equal the negative fourth root of 21. We do have both cases. Questions on this so far? Last step, we didn't need it last time. We just had to solve for x, yes? Is x by itself? Well, no. What's with it? Minus 3, yes? So what do I need to do to get rid of that 3? Add 3. Because our negative 3 plus 3 would be 0, leaving us with x is equal to 3 plus or minus the fourth root of 21. And especially whenever we have that plus or minus, we want to put whatever we add or subtract to both sides in front of the plus or minus, signifying just that fourth root of 21 is the positive and negative, not the whole thing. Questions on this here? Without approximating decimals or approximating anything, can I add 3 in the fourth root of 21? Well, no, we can't just do 3 plus the fourth root of 21 and get a number. They're not like terms, which means we also can't subtract, which means this is the final answer, because if we can simplify, if we can add and subtract those two terms, we need to add and subtract. If we're not able to add or subtract without approximating, getting rational numbers, we're going to leave it. Because I could grab the calculator and say 3 plus the fourth root of 21 to see that it's 5.140695143. 3 minus and it's also 0.859304857. We can do it in a calculator, but we can leave it as this here. Questions on this here? Five x cubed equals 320. First step is to get the term to a power by itself. So what do we need to do first? Divide by 5, because we need to get that x cubed term by itself. Because 5x cubed divided by 5 is going to be x cubed. 320 divided by 5 is 64. Is our term to a power by itself? Yeah, there's nothing else with it besides that cube, so we can deal with it now. And we can do that by taking the cubed root of both sides, because our cubed root and third power would simplify, leaving us with x is equal to cubed root of 64 is 4. Do I need the plus or minus on this one? No, because we took an odd root. There's only one real root. So it's just telling me x is equal to 4. Questions on this here? Questions on anything so far? We're ready for the next one. All right. Let's see here. Okay. Before we start this one here, I want to change it just a little bit. Come on. I know it's nice that I can fix this a little bit nicer. I want to change it to 256. $24. X plus 4. Okay. Got it fixed. X plus 4 to the 4th equals 256. Now, our term to a power is already by itself, yes? So that means we can go on and take the nth root of both sides. And in our case, it would be the 4th root. Those two would cancel, telling us that x plus 4 is equal to whatever the 4th root of 256 is. And the 4th root of 256 is 4. However, because we did take an even root of both sides, we took an even root of a positive number, we should have two solutions, yes? Which means we do have to put a plus or minus in front of that 4. Because x minus, or x plus 4 could be 4, or it could be negative 4. We could have either case. Last thing we have to do is solve for x. And what can we do to solve for x? Minus 4. Now, because of the plus or minus, we can't just directly subtract the 4 from 4. Because of the plus or minus, we don't just have 4, we also have negative 4. That's signifying both in one statement. So we can't just subtract 4 from 4 and get 0 and say plus or minus 0. They're two separate values. Questions on how we got x is equal to negative 4 plus or minus 4? Can I add negative 4 and 4 together? Because what is negative 4 plus 4? Can I subtract negative 4 and 4? So these here, I can actually add and subtract our two terms together, yes? We didn't approximate, we didn't round, we were able to add and subtract nicely, yes? If we're able to add or subtract nicely, we need to simplify it as far as possible. On the previous one, since the 4 through to 21 was not a nice rational number, we left it. Here, we can add and subtract, so we're going to add and subtract. Questions on this here? We're ready for the next one. X minus 2 cubed equals negative 14. Our term to a power is indeed by itself. So we can go on and take the nth root of both sides. Our cubed root and third power would reduce. Minus x minus 2 is equal to the cubed root of negative 14. I have a feeling that's not going to reduce. Let's clear all that out and try again. Cubed root, negative 14. It does not reduce to a nice rational number. Might as well just leave it. Last thing we have to do is solve for x. We can add 2 to both sides because our negative 2 plus 2 would be 0, leaving x by itself is equal to 2 plus the cubed root of negative 14. Because we already noticed or solved that this cubed root of negative 14 was an irrational number, it's not going to combine, it's not going to simplify without approximating. So we can leave it as 2 plus the cubed root of negative 14. If we really wanted to see what that is, it's not too hard to grab a calculator and say 2 plus the cubed root of negative 14, and it gives us negative 0.41. Questions on this here? Questions on anything we've done so far? We feel good with this here? Okay. That's it.